So far, when we talked about functions, we had functions taking simple values like an integer or a string or an array slice, for example. But now we're going to talk about something a bit different because we're going to talk about functions which take other functions as arguments. And this is completely possible thanks to the magic of closures. You can basically create a function as a closure and just stick it into some other functions for processing. So why would that be at all relevant? Why would you want to even do something like this? Well, let me give you an example of a simple algorithm that we're going to write in an imperative style, and then we're going to write it in a bit of a functional style. So let's have the sum of all the even squares of numbers less than or equal to 500. So I'll set the limit at 500 here, and I'm going to have a mutable variable called sum with an initial value of 0. And then what we're going to do is we're going to cycle through I having a value starting from 0 to infinity. So I'm going to leave this range open and just not give it a final value. And then inside this range, I'll calculate the I squared, which would be I times I. And then what I'm going to do is I'm going to check I squared. So if I squared is greater than our limit, then we're just going to break out of this loop completely. Otherwise, if everything is okay, then what we're going to do is we're going to check whether the variable is even, and we have a function here called isEven to do exactly that. A very simple function which just checks the remainder of division by 0. If it's in fact division by 2 rather. If it's 0, then it's an even number. So else if isEven ISQ, then what we do is we increase the sum accordingly. So we increase the sum by this square value, and that's pretty much all that we have to do, and we can actually print line the result. So when we use the loop, the sum is equal to this sum variable, and let's just run and see what we get. In this case we get 2024. Okay, so now what we can do is we can also use it in a functional way using some of the primitives that Rust has built in effectively. And these primitives are actually functions which take functions. So let's go through this slowly. So I'm going to calculate the sum. Let's call it sum2, but I'm going to do it differently. So I'm still going to begin by having this range from 0 to infinity. And this is how you define it. I'm doing it in round brackets so that we get a clearer understanding of what's going on. So now I put a dot in here, and I'll call a function called map. Now a map is something that takes a value and it can kind of transform it and turn it into another value. So we take the value x, and here it has to be a closure, so it has to be in a vertical bar. So we take the value x, and the first thing we did, remember, is we squared the value. So we take the value x and we multiply x times x, like so. So now that we're done, the end result of calling map, which, as you notice, map is a function which takes a function which does something. So we've essentially mapped x onto x squared. It's kind of like, you know, the basic definition of a function is that it's a mapping from one set to another set. Well, something like this is happening here with our range. So now we have effectively a set of squared values. So what we can do is we can now try and filter out all those values which are not breaking the limit. So we want to keep taking these values while the value is not greater than the limit. So effectively I can say something like this. I can say take while, and here I have to feed the reference to the values that we have. So ampersand x, and I have to basically say that the value that we have, which is x, is less than or equal to the limit, for example. So the take while will essentially ensure that we never take more values than, you know, what our limit specifies. Now next up, and we're still working with this sequence of values, we've now cut it to however many values we wanted in the first place. We can filter out the even values. So for that, we can use a function called filter, which once again, it takes an x here, and you can basically say that it has to be even. Is even, and x is a reference that we have to follow, so we can essentially put star x in here like this. So we are checking that each of the values is even. All the other values in the sequence, they're going to be thrown away, and we're going to be left only with the valid ones. And then finally what we do is we calculate their sum. And to calculate their sum, we use a folding operation. So a folding is the kind of operation where the right term folds onto the left term and it goes on to infinity. So starting with the initial value of 0, the folding operation takes the current value as well as the value that we're going to change. The current value, let's call it sum, and we're also going to have this value of 0 coming in for us, and we're going to do sum plus x. So this is how you do a sum of a sequence. You basically fold it onto itself, taking the initial value of sum to be 0 and changing the value of sum to sum plus x on each subsequent iteration. And that gets us our final value. We can actually print line this. So this is higher order function sum, and it's equal to sum 2. And let's just run this and see that we get, and you can see that we're getting the same result here. So this is essentially a demonstration of the fact that in certain cases you can write things in a different fashion where you're using functions which themselves take closures and operate on them. So this hopefully validates the idea of the usefulness of higher order functions.